Now we want to create a loop which we could control. There are a lot of jump instructions which are based on a condition. One of them is J and Z. For example, in here I say J and Z. What this instruction does is that it looks at a register called eFlags, which I think I explained in the previous modules. Let us just have a look at this register again in the Wikipedia page. In here, in the 64-bit architectures, the name of the register is rFlags. The first or low 32 bits is called the eFlags, and every bit is for some purpose. The high 32 bits are reserved for future users, as you see in here. Now what the J and Z operation or instruction does is that it looks at this specific flag or bit called 0 flag. This bit is the 7th bit or is at the index or position number 6. Now how this flag changes is that it looks if an arithmetic operation results to 0, this 0 flag would be set, and if not, it would be reset to 0. That's so important that you pay attention in both ways. If it is just one way, you wouldn't be able to use it. So what happens is that, again, if an arithmetic operation results in 0, the 0 flag would be set to 1, and in this case the J and Z could work with it, and if not, it would be reset to 0. So J and Z could just look at that specific flag and decide what to do based on that operation. If it is 1, then it wouldn't jump because the operation has resulted, one operation has resulted in 0, and if it is 0, well, it knows that the arithmetic operation hasn't resulted in 0. So in here, what we are going to do is to first create a condition based on which we are going to, the J and Z would decide what to do. So in here, I just want to use the R10 register, which is one of the general purpose registers in here, and move the value of 10, the number of times that we want the hello world to be printed on the screen. We could use other registers in here, but I decided to use the R10 register. Just pay attention, if you use RX register, you would have to do something else, because the syscall in here would return some value, which is the number of bytes which are printed on the screen, and it would save that return value inside the RX register. So you have to pay attention to that if you want to use the RX register. In here, I just want to use the R10 register. It's like just we use register like the variables in higher level programming languages. Now in here, we move the number 10 inside the R10 register, and in here I want to say decrement the R10 register. Decrement is for subtracting a value by 1. For subtracting, we use the sub. For example, if I say sub R10 and 1, it means that subtract the value in the R10 register by 1 and save it inside the register R10, which is just equivalent to dec R10. So what happens is that first this would get executed. You would have number 10 inside the R10 register. Then you would get to the move RX1 and all of these arguments which we explained in the previous lecture. Finally, the syscall would happen. The control would be passed to the operating system. The write system call would do its job, which is printing the hello world on the screen. Then the R10 value, which is 10, would be decremented by 1. Therefore, R10 would be equal to 9. And then this, since it has been equal to 9 and this operation hasn't resulted to 0, therefore the 0 flag would be reset to 0. Now when it's reset to 0, the J and Z operation would look at that flag, and because it is not set, so it would get executed and jump to the print. Again, all of these instructions would happen, and then it would get, and we would have another hello world on the screen. Then we would have R10 equal to 8. Again, because it hasn't been set, the 0 flag hasn't been set, or it has been reset to 0 again, so this instruction would take place again, and we jump to print. All of these things would happen until we reach the point which the R10 has been 1, and then it would decrement, it would be equal to 1. Therefore, the 0 flag would be set to 1 and this instruction wouldn't jump, so we get to this instruction, which is move RAX, move the value of 60 to RAX, and then exit would happen. If you don't quite completely get it, you will, because we are going to explain these things also using the GDB debugger. So in here I just want to press Ctrl O and hit enter to see if we have done everything right. So in here we say NASM, and I assemble it, create the object file, hit enter. Now use the linker in here to create our process or executable, and I run my executable and hit enter, and if you look, we have the hello world printed on the screen for 10 times.